Our second lesson today is going to be looking at sine and cosine curves and how making changes to the original equations affect the graph of the parent function. So if we start by graphing the sine of x in the domain from 0 to 2 pi, if we make a t-chart so we can graph our 5 critical points, for each value of x, I identify what is the sine of x. So my 5 critical points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right? If we remember back to the unit circle, the sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi, again, is 0. So if I graph those 5 critical points, I have 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi is again 0. If I want to see what happens to that graph when I change from y equals sine of x to y equals 2 sine of x, I'm just going to make another t-chart. Again with those 5 critical points. So I'm going to go 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, if the sine of x is 0 and I multiply by 2, that will still be 0. If the sine of pi over 2 is 1 and I multiply that by 2, that will become 2. Sine of pi is 0 times 2 is again 0. Sine of 3 pi over 2 is negative 1 times 2 will be negative 2. And the sine of 2 pi is 0 times 2, that's still 0. So if I graph those points, I'll have 0 at 0, 2 at pi over 2, 0 at pi, negative 2 at 3 pi over 2, and back to 0 at 2 pi. So if I connect those, you can start to see what putting the 2 out in front of the sine of x does to the graph. And what we can say is that it stretches the graph vertically. What it's doing, it's affecting the max and the min. If I put another t-chart in here to see what happens when I multiply the sine of x by negative 1/2, again, my 5 critical points, and changing the sine of x by multiplying by negative 1/2. So if the sine of x is 0 and I multiply by negative 1/2, still 0. Sine of pi over 2 is 1. I multiply by negative 1/2, that becomes negative 1/2. Sine of pi is 0 multiplied by anything, still 0. Sine of 3 pi over 2 is negative 1 times negative 1/2, gives me positive 1/2. And sine of 2 pi is 0, and again multiplied by negative 1/2 gives us 0. So if I graph those points of 0 at 0, negative 1/2 at pi over 2, 0 at 0, 1/2 at 3 pi over 2, and back to 0 at 0, at 2 pi, if I connect those points, you can see by multiplying by a number between 0 and 1 is going to shrink the graph vertically, but the negative sign is actually causing the graph to flip, right? What that's doing, it's affecting what's called the amplitude. And the amplitude is half the vertical distance between the max and the min. So if I want to find the absolute value of A, or the amplitude, I subtract the min from the max and divide by 2. So let's take a look at what happens if we change another part of the parent function. This time let's start with the cosine of x. So again, if I start with my t-chart and my 5 critical points, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. If we go back to the unit circle, the cosine of x is 1, the cosine of pi over 2 is 0, the cosine of pi is negative 1, the cosine of 3 pi over 2 is 0, and the cosine of 2 pi is again 1. So if I graph those points, I have 1 at 0, 0 at pi over 2, negative 1 at pi, 0 at 3 pi over 2, back to 1 at 2 pi. And if I connect those, I have my parent function for y equals cosine of x. Trig functions are what are called periodic functions. It's how long they go before they repeat what they look like, essentially. So they have what are called cycles or periods. So the entire graph of cosine can be seen from 0 to 2 pi. So we say the period of y equals cosine of x has a period of 2 pi. So if I start a new t-chart over here and I change the value in front of the x, so now I'm going to graph the cosine of 2x. Again, let me start with my critical values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now what I'm going to do is multiply what I'm plugging in. So I'm going to multiply 2 times 0 and then take the cosine. Well, 2 times 0 is still 0, and the cosine of 0 is 1. At pi over 2, if I multiply that by 2, I'm going to get the cosine of pi, which is negative 1. If I plug in pi, multiplied by 2, I'll have the cosine of 2 pi, which is back at 1. And 3 pi over 2 times 2 would be 3 pi. And the cosine of 3 pi, well, that would be coterminal with pi, so that would be negative 1. And 2 pi times 2 is going to be 4 pi, which is coterminal with 2 pi. So cosine of 2 pi, again, is 1. So if I start to graph those values, I have 1 at 0, negative 1 at pi over 2, 1 at pi, negative 1 at 3 pi over 2, and 1 again at 2 pi. Well, I know I have to follow that shape of a cosine curve, so I'm going to have to go down to negative pi over 2, back up at pi, back down to 3 pi over 2, and back up to 2 pi. So what you should notice is that you see the entire cosine curve over a shorter period. Now I see the entire cosine curve between 0 and pi. So here I would say that the period is equal to pi. How can we say that 2 is having an effect on the graph? That 2 cuts the period in half. So now let's take a look at what happens if we change the value in front of x to something between 0 and 1. So I'm going to change it to 1/2, and I'm going to make myself a little t-chart. Right? Again, I've got cosine of 1/2 x. And I'm going to go with my critical points, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. So if I put in 0 for x and multiply by 1/2, that's still 0, and the cosine of 0 is 1. If I put in pi over 2, multiply by 1/2, that's going to become pi over 4, and the cosine of pi over 4 is rad 2 over 2. If I put in pi, multiply by 1/2, I want the cosine of pi over 2, that's 0. If I put in 3 pi over 2, that's the cosine multiplied by 1/2, then would be the cosine of 3 pi over 4, which is negative rad 2 over 2. And putting in 2 pi and multiplying by 1/2 gets me the cosine of pi, and the cosine of pi is negative 1. So if I now plot those points, 0 I'm at 1, at pi over 2 I'm at rad 2 over 2, which is about 0.7-ish. At pi I'm at 0. At 3 pi over 2 I'm at negative rad 2 over 2. And at 2 pi, I'm at negative 1. So if I connect those points, what you start to see is over the domain of 0 to 2 pi, I'm only seeing half of the cosine curve. If I wanted to see the entire cosine curve, I would have to go that far again. So if I'm seeing half of it from 0 to 2 pi, I would have to go from 2 pi to 4 pi to see the entire cosine curve. So here we have a period that's equal to 4 pi. So what we are noticing here is that we have a new form of our parent function where we've changed the value in front of x. So if we look at it and say, well, that's in general terms, y equals the cosine bx, then the period of the graph we can define as the period is equal to 2 pi over that value of b. Or I can rewrite that and say that b is equal to 2 pi over the period. So let's sum up what we just learned. If we have a sine function, we know that that starts at 0 or somewhere what we call a midline. If we have a cosine function, that's going to start at a max or a min. We found out that A stands for amplitude, which has to do with the vertical stretch, and we find the absolute value of the amplitude by subtracting the min from the max and dividing by 2. We learned that the value of B affects the period, or the horizontal stretch, and the period is equal to 2 pi over B, or B is equal to 2 pi over the period. So now we should be able to start drawing the graphs of sine and cosine functions that have an amplitude and some value of B that's changing the period. And we should start to be able to graph those pretty quickly, finding just 5 critical points, right? The equation y equals 2 cosine 1/3 x. We should be able to look at that and say that the amplitude equals 2. So it's going to look like a cosine curve, but the amplitude is going to stretch the graph so that the high and low goes higher and lower. The value of B is equal to 1/3, which means the period is 2 pi over 1/3, or the period is now equal to 6 pi, which means things are happening slower. So I have to go farther to be able to see the entire cosine curve. So if I go all the way out to 6 pi, half of that would be 3 pi. Half of that would be 3 pi over 2, and halfway between 3 pi and 6 pi would be 9 pi over 2. And then we know that a cosine curve starts at a max. The value of A is positive, so it's right side up. So at 0, I'll be at 2. At 3 pi over 2, I'll be at 0. At 3 pi, I'll be down at -2. At 9 pi over 2, back at 0. And at 6 pi, back up to 2. So I probably should have labeled these on the side here. Right? So over the period of 2 pi, I will see the entire cosine curve. Versus the one at the bottom, that's a sine function, the amplitude is 4. So I know it's going to go higher and lower in terms of being, oops, these should have been negative, in terms of being vertically stretched. The negative sign says it's going to be flipped. The fact that it's a sine curve says it starts at 0. And a B value of 3 now says that the period is 2 pi over 3, which means things are going to happen faster. So I'm going to see the entire sine curve between 0 and 2 pi over 3. So half of that would be pi over 3, half of that would be pi over 6, and halfway between pi over 3 and 2 pi over 3 would be pi over 2. So I know that a sine curve starts at 0, and I know that halfway it's back to 0, and when I get to the end, it's also at 0. And I know somewhere in between those values of 0, I go to a max or a min. Well, because my max and my min are now with an amplitude of 4, but the sine curve is flipped, then halfway in between, I'm going to go down to -4, and halfway in between here, I'm going to go up to +4. And now I'll see my sine curve looks something like that. We should also start to be able to look at the graph of a sine or cosine curve and write the equation for it. So if I look at the example 4 in letter A, I see that that starts at a max and goes down to a min and back up to a max again. That's a cosine curve. If I want to know what the amplitude is, I'm going to take the maximum, which is 3. I'm going to subtract the minimum, which is -3, and I'm going to divide by 2. So I've got 6 divided by 2, or I have an amplitude of 3. I can see from the graph that I have a period of 8. So if I want to know what my b value is, I take 2 pi and divide by the period, which becomes pi/4. So in general, that curve is going to look like y equals a cosine b of x. So that'll look like y equals, the amplitude is 3 and that cosine curve is right side up. So 3 is positive. Cosine, the value of b is pi/4 and then times x. So just by looking at the graph, I can write the equation of that curve. Likewise, if I look at example B, I see that that looks like a sine curve because it starts at 0 or at the midline. So I can see that that's a sine curve. If I want to find the amplitude, I'm going to take the high value, which is 2, subtract the low value, which is -2, and divide by 2. So that'll be 4/2. So I have an amplitude of 2. The period is pi/2, right? I see the entire sine curve between 0 and pi/2. So b is equal to 2 pi divided by pi/2, or 4. So in general, that equation will look like y equals a sine bx. Now my amplitude is 2, but that sine curve is flipped upside down. So here will be -2 and then sine 4x. So the graph in B is y equals -2 sine 4x.